Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss the problems from set theory, in fact from Venn diagrams, and particularly I'll be taking the concepts and problems of basically based on maximum and minimum values problems. Okay, so let's begin the session. Though I have already explained you the basic, then also we just go for a quick recap. Suppose I have two circles, right? Two sets, set A and set B, right? Now this is the common region between set A and B, and we denote it as A intersection B, right? This complete circle is of B, this complete circle is of A, this region is A intersection B, and the entire set, the combination of these two circles, it is known as A union B. That is the total of these two circles, right? And the formula that we use over here, that is number of elements in A union B is equal to number of elements in A, that is this total circle, plus number of elements in B, that is this circle, minus number of elements in A intersection B, right? Why we are deducting it? See, when you are taking NA, number of elements in A and A, you are taking this value of this entire circle, and then when you are taking number of elements in B, then you are taking this complete value. So this particular portion is being calculated twice, so once we need to deduct, right? So number of elements in all will be, or universal set will be, number of elements in A, number of elements in B minus number of elements in A intersection B. Similarly, if we have three circles like this, so that is A, B, C, then number of element in A union B union C, that means total number of elements in these three sets or circles, that is number of elements in A plus B plus C minus number of elements in A intersection B plus B intersection C, number of elements plus C intersection A, right? And plus number of elements in A intersection B intersection C. Now I just tell you, this is set A, this is set B, this is set C. Now this region that is common to all, that is included in A, B and C, that is this A intersection B intersection C. I suppose it to be X. Okay, now this region that is common between only A and B, or exactly between A and B, right? So that is this. Okay, this is actually A intersection B, that this complete portion, but if only if we have to see on the area which is common between A and B only, then this is the area. Similarly, between B and C, only this and this, right? So the total of this entire we can say the three sets will be A union B union C, right? Now next thing is, suppose I name the regions, that is A, B, C, D, E, F. Now you must be knowing the definition of each and every variable over here. Now suppose I take a very simple example, maybe A, B, C are three newspapers, different type of newspapers, and this A, B, C, E, F, T, the data inside these three circles is a number of persons who like these newspapers, right? Over here A is the number of person who like only newspaper A, C is the number of person who like only newspaper B, F is the number of persons who like only newspaper C. Similarly, B is the number of person who like two newspaper, exactly two newspaper, that is A and B. D, number of persons who like exactly two newspaper, that is C and B. Similarly, E is the number of persons who like exactly two newspapers, that is A and C, right? And X is the number of persons who like all the three newspapers, right? So if you are asked about how many persons like maybe newspaper B, right? So newspaper B is liked by C plus B plus X plus D, this entire circle. Now how many persons like newspaper B and C? So you need to choose the common region between B and C. B and C, that doesn't mean only B and C. B and C, that means the portion that is common between B and C. So B and C is this, that is D plus X. So the number of persons who like the newspapers B and C both is X plus D. But if you are asked the number of persons who like only newspaper B and C, only B and C, then it will be D only, because X is being liked by X is liked by A also, right? So this is how the calculation or the concept goes. Now we'll be taking practical problems to understand these concepts in better manner. So I take first problem. Now as I have already told you, in this session I'll be taking the problems based on maximum minimum value only. To understand the basic or to be able to solve the basic problems, you need to understand the basic sessions of Venn diagrams, right? Now here this problem, according to a survey, at least 70% of people like apples, at least 75% like bananas, and at least 80% like cherries. What is the minimum percentage of people who like all the three? Now the first thing over here is you should be knowing, see, the percentage, total percentage value should not exceed 100%. Here we are having 70 plus 75 plus 80, right? 80 plus 70, 150, 150 plus 75, 225%, right? But the total percentage should not exceed 100. That means there is some overlapping, right? Now how do we solve this problem in just seconds, that I'll tell you later on, but first of all we just go for a Venn diagram. Though you don't need, but for conceptual clarity I'm just doing it. Now there are apples, bananas and cherries. Now total of this circle is 75. Total of circle B is 70, this is 70, this is 75 and this is 80, right? Now as I have already told you, the total should not exceed 100. That means these areas are also filled up, right? Then only it is possible to make this total as 100. That means precisely A union B union C is restricted to 100. That means these regions have some values. As I've already told you, the formula A union B union C is equal to A plus B plus C minus intersection of A, B, B, C, A, C, and minus plus intersection of A, B and C. Now in this case we have to find out the minimum percentage of people who like all the three. That means precisely we have to find out the minimum value over here, that will be over here, right? Now to be able to solve this sort of problem, you don't need Venn diagram, I just do it for the conceptual clarity only. Now see, we have the restriction of 100%, right? So we are having 125% extra, right? Now just listen to me carefully, how would we proceed? See, 70% people like apples and 75% like bananas, right? And we have restriction of 100%. So 70 plus 75, that is actually 145%, right? So, and we have limitation of 100%, that means 45% is included between these two. See this, 70, 75, right? If I write 45 over here, and 70 minus 45 is 25, and 75 minus 45 is 30, right? This is apple, this is banana, and this is both. Now 40, 50, 60, 70 and 30, it is 100. That means 45% people like A and B both, right? We have to maintain the total to be 100, because percentage at max it can be 100, right? So 70 plus 75 minus 100, that means 45% people like both. They are included in this also, they are included in this also. Now 45% like both apple and banana. Now this 45 and next 80, again the total should not exceed 100%. So 45 plus 80 is what? 125, right? And the total should not exceed 100. So we have 25 extra, that means 25 is there, right? See, 45 is the number of people who like banana and apple both. 80% like cherries. So if we take intersection of these two, we'll have 25 as common. I just draw this circle over here. This is 25, this is 45 minus 25, that is 20, and this is 80 minus 25, that is 55, right? So this total comes to 100. That means 25 people are common between cherry and the other, and the other is exactly nothing but the common area between apple and banana, right? So precisely 25% people like all the three, right? Now in short, how could you solve this problem? I have explained the concept. Just keep on deleting the maximum value, right? 70 plus 75, that is 145, delete 100, you are left with 45. 45 plus 80, 125, delete 100, you are left with 25. So that will be the minimum value of all three, right? So in seconds you can solve this problem if you are conceptually clear. I did this entire work only for conceptual clarity. Otherwise in exam you can do this problem in 20 seconds, not more than that, right? Now here on the similar concept we solve this problem. A survey was conducted on a car brand Khatara. It was found that 60% of the vehicles had problem with their engine, 60% had problem with doors, 50% with tires, 20% had no problem, right? Again, our total is restricted to 100%, right? And 20% is having no problem. That means now the problematic area or the problematic cars 80%, right? That means our entire total should be restricted to 80%. Now as I told you in earlier case, we have to restrict ourselves with 80, up to 80. Now 60 plus 60, 120, right? 60% is having engine problem, 60% is having door problem. So 60 plus 60, 120, 120 minus 80, that means 40% are having both the problems, that is engine problem plus door problem. So this is engine plus door. Now plus 50. So 40 plus 50, 90. This 50 is tires, right? So again this is exceeding 80. So 10% is having engine plus door plus tire. So minimum percentage of vehicles which had all the three problem is 10%, right? So precisely what I have done, 60 plus 60, 120, 120 minus 80, that is 40, 40 plus 50, 90, 90 minus 80 is 10. So our answer is 10. Okay. On the similar concept, we have this problem. A survey was conducted among a group of 50,000 people who preferred, here there are 5 types of newspaper, right? In the earlier cases we were having only 3 sets, now we have 5 sets, 1, 2, 3, 4, 5, right? And 4,000 did not like any of these newspaper. Now 50,000, 4,000 out of 50,000, that is 46, that means 92%, right? So this calculation should be restricted to 92%, right? Now how would we proceed? We have to find out the minimum number of people. When you have to find out minimum number of people, you have to proceed in the same way as we did earlier, as we have done earlier. Okay, so find the minimum number of people who liked all the 5 newspapers. Now we have to restrict the total to 92. Now 90 plus 85, it is 175, right? From 175 you deduct 92. So that is 75 plus 8, that is 83, right? Now that 83 and 80, we have taken this, 83 plus 80 is 163. From 163 you further deduct 92. So 63 plus 8, 71. Now that 71 plus 82. So that is 71 plus 82, 153. From 153 you further deduct 92. So that is 53 plus 8, 61. Now that 61 plus 75. So 61 plus 75 is 136. Now from 136 further you deduct 92. So 36 plus 8, 44. So 44% people are there who are included in all the 5 sets. That is a bare minimum value. That means the minimum number of people who like all the 5 newspapers are 44% of 50,000, right? So 44% of 50,000, that must be 22,000, right? So how easily you can solve this sort of problems if you are conceptually cleared. Okay. Let's move one step ahead. In a class of 50 students, a test for 2 subjects was conducted. 30 passed in the first subject and 40 passed in the second subject. Okay, I just draw the diagram over here. What is the maximum number of people who passed in both the exam? What is the minimum number of people who passed both the subjects? Okay, so minimum number of people, as we have already discussed, see, we have limitation of 50, right? So 40 plus 30, 70 minus 50, this must be 20. So minimum number of people who pass in both the exams, in both the subjects, must be 20. Now maximum number of people, I just explained this concept of maximum. See this subject 1 and subject 2. 30 passed in first subject and 40 passed in second subject. Now this is 30 and this is 40. Maximum number of people who passed in both the subject. See, we have found the minimum value of this intersection, that is 20. Now we have to find out the maximum value of this intersection. Now maximum value out of 30 and 40, at max it can be 30, because it should not be less than 30, because you'll be getting the negative value over here, right? So we have to see whether 30 suits over here or not. So suppose I put 30 over here, right? So if I put 30 over here, it will be 0 over here. If I put 30 over here, I'll be getting 10 over here. So the total is coming under 50. That means at max 30 people who passed in both the subjects, right? So this is 30 and this is 20. Okay, I hope you are getting it. Now this problem, here we have to find out the maximum and minimum value of all the 3 activities and exactly 2 activities. So here we'll be able to understand all the concepts, right? In a college where every student follow at least one of the 3 activities, drama, sports, arts, okay, arts 65% follow, drama 86%, and sports, okay, I'm sorry, 65% follow drama, 86% follow sports, and 7% follow arts. What can be the maximum and minimum value of student who follow all the 3 activities? So minimum 3 activities, that can be seen through surplus or by the same method, 65% plus 86%, right? 80 plus 60, 140, 140 and 151. Out of 151 we need to deduct 51 to make it 100%, right? So 51% people follow drama and sports both, right? Now that 51 plus 57, so 51 plus 57, that is 108. That means 8 is extra, 8 is surplus, so that 8% is the minimum value who are engaged in the 3 activities, right? 8% minimum in 3 activities. Okay. Now I just draw the diagram over here. See, these are the 3 sports, arts, drama and sports. Okay, now this minimum value we have found to be 8%. So minimum value of this region is 8%, right? And this total circle must be 100%. So at max these 3, right? These 3, that is exactly 2 activities. So if this is minimum, this will be maximum, right? Just listen to me carefully. If this is minimum, the sum of these 3 will be maximum, right? And maximum sum is 100, right? So if this is 8, this total must be 100, so these 3 can be 92. So maximum value of these 3 must be 92. So exactly 2 activities, maximum value is 92. When this is minimum, this is maximum. When this is maximum, this is minimum, right? Now we find we have done maximum number of people doing exactly 2 activities and minimum number of people doing exactly 3 activities, right? Now we have to find out maximum number of people doing 3 activities and minimum number of people doing exactly 2 activities, right? So just listen to me carefully. Now I have to find out the maximum value of this region. So at max it can be 57, right? But whether it is applicable or not, whether it is correct or not, that we need to check. right? So if I write 57 over here and put 0 0 0 over here, right? So see, the total of this circle, that is arts, is actually 57%, so it is 0 over here. Now this total of this circle, that is drama, is 65, so it must be 8 over here. And the total of this circle, that is sports, is 86, so 57 is here, so 29 must be here. Now the total of these three must be 100, but it is not 100, it is coming out 57 plus 8 65, 65 plus 30 95, that is 94. So the total of all these is 94, right? So still we are left with 6. Okay, that means 57 cannot be the maximum value of the persons who are doing all the three activities, right? Now what if I deduct 1 from here? If I reduce, just try to understand the concept. Later on you'll be able to do it without this work also. If I make 56 over here, right? So if it is 56, the total of this circle is 57, so I should be having 1 over here. Similarly, it should be 65, that means I should be having 9 over here. Similarly, this should be 86, so I must be having 30 over here. Now this total, the new total, if you see, earlier it was 57, 0, 8 and 29. Now the new total is 9 plus 1, 10, 10 plus 56, 66 and 30, 96. The previous total was 94, now the total is 96. That means if you reduce 1 from here, the total increases by 2, right? Listen to me carefully. If you deduct -1, then total increases by 2. Now what, how much increase we want? From 94 to 100, we want 6 increase, right? So for 1 decrease, 2 is gained. For 2 decrease, 4 will be gained. For 3 decrease, 6 will be gained. Okay, if I deduct 1 from here, the total increases by 2. If I deduct 2 from here, the total increases by 4. If I deduct 3 from here, or the total increases by 6, right? So if I deduct 3, that means instead of 57, if it is 54, then the total will be 100, right? So at max it can be 54. When it is 54, these three are 0, right? So minimum value of these three is 0. Okay, and if it is 54, then this must be 3, 54, and this is 65, so 54, 65, this is 11, and 54, 86, that is 32, right? And now we got the maximum value of the persons who are doing all the three activities is 54, and minimum number of people who are doing exactly 2 activities is 0. Okay, so that was very interesting and very important, right? And particularly this concept, when you reduce 1 from here, the total gets increased by 2. If you deduct 2 from here, the total gets increased by 4. That is the funda you will be using a lot of times. Okay, so, and I'm sure you might have got the concept. When this is maximum, this is minimum, this is minimum, that is maximum, right? Some cases will be there when you have to see these overlaps also, but let's see. Take next question. Now the similar concept, or I can say same concept, we try these 3-4 problems. In a survey, 100 people were asked about their favorite holiday spot in India among 3 places: Goa, Shimla, Kashmir. All the people had at least one of these 3 spots as their favorite one. 90 people named Goa as their favorite spot, 80 Shimla and 80 Kashmir. Okay, I just draw the diagram over here. So it is Goa 90, Shimla 80 and Kashmir 80, right? Now the first question, determine the maximum number. First of all, we find out the minimum number of people who could have named all the 3 places as their favorite spot, right? Again, we'll follow the same strategy. 100 is a limitation. So first of all, 80 plus 90, 170. 170 minus 100, we are left with 70. 70 plus 80, 150. That means 50 people are surplus. So 50 people that is the minimum number, have named all the 3 places, right? So that is 50. Okay, now when this is 50 minimum, so when this is minimum, these 3 will be maximum, right? And the sum is restricted to 100. So if it is 50, that is a minimum, or I just name, suppose it is A, then B, C, D, right? A plus B plus C plus D, it has to be 100, and when A gives a minimum value, that is 50, then B plus C plus D will be maximum, but that also will be 50, right? Because the sum is restricted to 100. So minimum value is 50, minimum value when the number of people who could have named all the 3 places is 50, and maximum value when number of people who could have named exactly 2 places as their favorite is 50, right? So B plus C plus D max is 50. So we have solved these 2 problems. Now we have to see the maximum number of people who could have named all the 3 places as their favorite. Now how do we do this? At max 80 can be common, right? At max 80 can be common. It's not the correct answer, but we are starting from here. Now if it is 80, it's 10 over here, it's 0 and it's 0. In that case total number of people are 90, but we want the total number of people are 100. So we are short with 10, right? We are short with 10. So if I make 79 over here, then I'll be getting 11 over here, 1 over here and 1 over here, right? So in all now 79 plus 11, that is 90, and this is 92, right? So if I reduce 1 over here, I get 2 more than the previous calculation. So if 1 is deducted, we get 2 more. If 2 is deducted, we'll get 4 more. If 3 is deducted, we get 6 more. If 4 is deducted, we get 8 more. If 5 is deducted, we get 10 more. So the shortfall of 10 can be compensated if we deduct 5 from here. So we started with 80, and instead of 80, if we take 75 over here, if this is 75, then if a shortfall of 5, then 10, the total will be more by 10, right? You can verify also, if it is 75, here it will be 15, here it will be 5, and here it will be 5. So 75 plus 15, that is 90, and this 100, right? So at max it can be 75, it cannot be more than 75. So this is the correct choice. Now you see, when we are taking the maximum value of this, we are filling this area, that is exactly one area, right? So we are not having any data in these 3 areas, that is exactly 2 area, right? So when this is maximum, it is minimum, and the minimum is 0. So that is the answer. So this is how you can solve all the 4 questions, right? And this logic is really important. If you deduct 1 from here, the total is increased by 2. Okay. Now let's see this. 20 friends including the host decided the party on a festive Saturday night in a bar. The host knows that 15 of them can have whiskey and 10 of them can have rum. 15 whiskey, 10 rum. He also knows that each of them have 4 packs of any drink. None of them has both whiskey and rum simultaneously. Every pack of whiskey costs rupees this, rum this. What is the maximum and minimum budget that the host would have planned for? Assume that at most 5 people can go without drink in the party. Okay, so first of all we calculate max budget, right? Okay, at most 5 people can go without drink in the party. They can go, but it is not necessary, right? So first of all, since whiskey is costlier, we assume that 15 persons are taking whiskey, right? 15 of them can have whiskey, so all 15 are taking whiskey, and 5 people are taking rum. Now 15 people, each is having 4 packs, each worth 60 rupees, so it is 3600, and remaining 5 people, they are taking rum, right? So 5 into 4 into 30, so it is 600. So the total budget is 4200. That is a maximum budget, right? Now in case of minimum budget, we do not consider these 5 people because they can go without drink, right? Now maximum people who are taking rum is 10. So rum, 10 people, 4 pack, each 30 rupees. So it's 1200 rupees. Remaining 5 people, 4 pack, 60 rupees. So that is 1200. So that is minimum budget 2400 and maximum budget 4200. Right? Pretty simple. Now see this one. It is a bit different from the previous ones and important also. So just see carefully. There are 3 electives offered to the students class of 92, having a choice of not choosing any elective. See, 92 is the maximum figure, but there's a calculation which is given over here that it is really not necessary to add up to 92. It can add up to 92 or less because they have choice of not to choose any electives, right? Now 60 students opted for marketing, 80 for finance, 50 for systems, 40 for both this. Okay, so to be able to solve this sort of problem when maximum number is not fixed, you should go on the reverse manner, right? Now what's that? I just draw the Venn diagram. Okay, we have marketing, then we have finance, and we have systems, right? Reverse method, that means you start from here, right? I assume this to be X. Okay, that is the intersection of marketing, finance, and systems. That means the students who have opted for all the 3 streams, right? Now we go marketing in all, it is 60, finance in all, it is 80, systems in all, it is 50, right? Now marketing and finance, 40 students opted for both marketing and systems, 40 between marketing and system. So marketing and system, this total should be 40. Now if it is X, it must be 40 minus X, right? Similarly 50 for marketing and finance. So marketing and finance 50. So if this is X, it must be 50 minus X. Similarly 45 for finance and systems. So if this is X, it must be 45 minus X, right? Now the total of this circle is 60. Okay, so it must be 40 plus 50, 90, that is, it must be X minus 30, right? Then here it is the total to be 80. So 50 plus 45, that is 95, 80. So it must be X minus 15. Then 40 plus 45, 85 minus 50, that is 35. So it must be X minus 35. Now this is the Venn diagram we have drawn. Now what is the maximum and minimum possible number of students who opted for all the 3 electives? We have to find out the maximum and minimum value of X, right? Now you can see X, minimum value of X, if we find, it must be more than 35. Why? Because if it is less than 35, this quantity will be negative, right? Inside these 3 intersections, these 3 overlaps, X is actually negative. So here it doesn't matter, but in these 3 cases X is positive, right? So X minus 35, X minus 30 and X minus 15, all of them should be positive quantities. At max they can be 0. Any of them can be 0, right? So minimum value of X must be 35, right? Below 35 this quantity will be negative. So minimum is 35. That's for sure, right? Now we have to find out the maximum value of X. See, my maximum total of these entire set, that is union of this set, is 92, right? Sum of all these data should not exceed 92, right? So I can equate the sum of these to 92, right? So what I'll be doing, X, 1 positive, negative, negative, positive, negative, positive. So I'm just left with one x positive, right? After that it is a 50 minus 30, I'm left with 20, positive 20, 20 minus 15, 5, a positive 5 plus 45, 50, 50 plus 40, 90, 90 minus 35, 65, right? So x plus 65 is equal to 92. I'm sorry, 90 minus 35 is 55. So x plus 55 is 92, or it should be less than equal to 92. So x should be less than equal to 92 minus 55, that is 37. So maximum value of x is 37 and minimum value of x is 35, right? So this is how you can solve when the maximum number or the total is not fixed. Okay, and that's really important. I hope you are clear. Now this question: in an office where working in at least one department is mandatory, 78% employees are in operations, 69 in finance, 87 in HR. What are the maximum and minimum percentage of employees that could have been working in all three departments? Right now maximum 100 is fixed, right? Once again we'll follow the same method to find the minimum percentage of employees working in all three departments. Now 78 plus 69 minus 100. So that is 70 plus 77, that is 147 minus 100, that is 47. Then 47 plus 87. So 80 plus 40, 120, 120 plus 14, 134, right? So excess is 34. So minimum percentage of employees who are working in all three departments is 34%. Okay, that's pretty simple. Now we have to find out the maximum value, right? Again we'll go for this. Here it is 69, 87 and 78. So if we start from 69, I write 69 over here. So it must be 0 over here. Then 69 and 87, the difference will be 18. 69 and 78, the difference must be 9. So this total, that is 69 and 9, 78, 78 plus 18 is 96, right? But we want it to be 100, right? So we have to gain 4. So if we have to gain 4, we need to reduce 2 from here. As we have already discussed, if you deduct 1, the total will be increased by 2. If you deduct 2, the total will be increased by 4. Now we want the increase of 4, that means we need to deduct 2. So instead of 69, it should be 67. Right? So 67 is the maximum percentage of the employees who are working in three departments. Okay, very simply you can solve. And if you wish to verify, you can verify. If it is 67, it must be 11. If it is 67, it must be 2. If it is 67, it must be 20. So this total will come up to 100. Okay, so that's pretty easy and interesting. Okay, now the set of questions, 4 questions are there. In a school there are 200 students, 100 play cricket, 50 hockey, 60 basketball, 30 cricket and hockey, 35 hockey, basketball, this. What is the maximum possible number of students who play at least one game, right? Again, in this case the total number is not fixed. It is not necessary that all the 200 students are playing at least one game, right? So again we just have to take the reverse method. So I draw the Venn diagram. That's okay. So I assume this to be cricket, this to be hockey and this to be basketball. So cricket 100, 50 and 60. Okay, cricket is 100, hockey 50 and basketball 60. I assume this value to be x, right? Now 30 students play both cricket and hockey. So cricket and hockey, 30 students. So this will be 30 minus x, right? 35 students play hockey and basketball. Hockey, basketball 35. So it must be 35 minus x. And 45 cricket and basketball, so it must be 45 minus x. Now the total of the circle must be 100, right? So we have positive x and 45 plus 30, 75. So we have x plus 25 over here, right? Similarly 30 and 35, 65 and 50 will be negative, so it is x minus 15. Then we have 45 and 35, 80 and 60, so it must be x minus 20. So this is the Venn diagram. Now we have to find out the maximum possible number of students who play all the 3 games and minimum possible number of students playing all the 3 games. So maximum value of x and minimum value of x. So minimum value of x must be 20, otherwise x minus 20 will be negative, right? So minimum is 20 and maximum it should be 30, otherwise 30 minus x will be negative. So these 3 questions we answered very easily. Right, now to be able to answer the remaining 2, that is the number of students who play at least 1 game and maximum number of students play at least 1 game and minimum number of students play at least 1 game. So that we do. Right, now what is this? The total of this all this should be less than 100, right? So what I do is I just add up all of them. See here, x positive, negative, positive, positive, negative, positive, negative, so precisely we'll be left with 1x plus then 25, 45, that is 40, 50, 60, 70 and 30, 100, 100 and 35 minus 35, right, minus 20, and so it is precisely total of this is x plus 100, right? So we have to find out the maximum and minimum value of x plus 100, right? X plus 100 is the number of persons who are playing at least 1 game, right? Because this is the total of the people who are playing at least 1 game. So x plus 100 is the number of persons who are playing at least 1 game, right? So minimum value of x will give us the minimum value of persons who are playing at least 1 game, and maximum value of x will give us the maximum number of persons who are playing 1 game, right? So minimum value of x is 20. So minimum 120 people are there who are playing at least 1 game. Minimum possible number of students playing at least 1 game, that is 120, because minimum value of x is 20 and maximum value of x is 130. So maximum students who are playing all the 3 games will be 130. Okay. Once again, the total of this is x plus 100 and it is nothing but the total number of students who are playing at least 1 game. It is not necessary that it is 200, right? This total is not 200. This total is x plus 100. So maximum value of this expression will be dependent on x. Maximum value of x will provide the maximum value of the students who are playing at least 1 game, and minimum value of x will provide the minimum number of the students who are playing at least 1 game, right? So using this Venn diagram we have solved all these 4 questions in just 1 minute, right? So you will take 1 minute to draw this Venn diagram and 1 minute to answer all the 4 questions, right? So in all 2 minutes you can solve all the 4 questions. So a good number of problems based on Venn diagram we have discussed in this session, and from my side I have taken each possible pattern that is available with me, right? So you just can practice with Venn diagrams. Just revise this session once again, and I'll see you in the next session. Bye bye.